Okay, hi guys. Now today we are going to talk about one aspect of abstract algebra. That's devices. We're going to talk about devices. Now we'll start by first explaining what are devices. Now, when you say devices also known as the factors are numbers that are able to divide a number. So if we have this number like this, we have 4. Then we are to list the divisors of 4 or the factors of 4. They are 1, 2, and 4. So all these factors or all these devices are able to divide 4. That is why we call them devices. So if you have 4, then I divide by 1 is 4. Then if I have 4, then 2 divides 4, then you get 2. Then 4 divides 4 is 1. So now let's move to the next aspect. Okay, so let's continue. Okay, now if you read this statement carefully, it said if you have AB such that this AB belongs to a set of integers, that's the Z, this Z represents the set of the integer sign. With D, which is not equal to 0, then D is said to be the divisor or the factor. So if D is the divisor and that's not equal to 0, or it's a factor of 0, because so obviously if D is equal to 0, then I think the number is 0, so we can't divide any number. So D is the divisor. Then there exists an element of Q of Z such that A equal to QD. If D is a divisor of E, we say that D divides A, or A is divisible by D. Okay, so now let me explain this equation here. So we are saying that if I have a number A equal to Q, where Q represents the quotient, then if I multiply by D, then I will get that number. D, which is the divisor, if I multiply by it, I'm going to get that number. So let me give an example. So let's use the example above from the first one. So if I have 4, then I have a divisor. The divisor, that is 2. 2 to be its divisor. So 2 divides 4, yeah. Then this 2, if I multiply it by a quotient, that's 2. Then if I multiply it, it's the same thing, because if I have 2 which divides 4, then I multiply by quotient 2, it gives me 4 back to 4. So the Q is the represent the quotient. So what this equation simply, let's equate this to what I've written here to relate it to the example. So this represent the A, or represent the A, then Q, then this one is the D. So this can be compared to the example above then to help in our understanding. So normally we write D divides A to indicate that D divides A. So we introduce this slash as the divisible sign. So say D divides A. Okay, now let's continue. Let's move to the next aspect. So this aspect, we are going to talk about the GCD. That's the greatest common divisor. Greatest common divisor. So basically, what this simple means is that if we have 2 numbers, then we are able to find their divisors. Then we are able to extract some common divisors among them. We can find the greatest. So if D divides B, then D divides C. We call D a common divisor of B and C. In addition, every common divisor of B and C is also a divisor of D. We call the greatest common divisor of B and C. So what this statement means, let's use an example to explain it for us to get a better understanding. So if you have 18 then 12, then we have to find the common divisors. So if you're able to list the divisors of 18 then 12, we could realize that 18, the common divisors of 18 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 6. So these are the common divisors of 18 then 12. So these are the common divisors of 12. And we are able to, if we're able to list their common divisors, then you're able to find the GCD as the greatest common divisors. So that is basically, this is the concept. The concept of the GCD. Sometimes we allow the name to even scare us, but basically this is what it means. So it shouldn't take any. Now, for the purpose of our study, we are going to limit ourselves to only positive divisors. So if we are able to list the divisors of the common divisors of 18 and 12, then obviously we could see that the 6 is the greatest among all of them. So the GCD is 6. The GCD is 6. So when we are asked to find the GCD of any number, then you're able to list all the common divisors of these two numbers, and you pick the great one, that becomes the GCD. Okay, now let's continue. Let's try to extract, I think, a common equation for the division algorithm. So this is a division algorithm. This we are going to discuss. Now this one states that for any two non-zero integers a and b, there exists a unique integers q and r called quotient and remainder respectively, such that a is equal to bq plus r. So I think from the other aspects, when we talk about this, the equation, the divisors, where we're able to extract this equation, is the same thing that we are going to build on this to get this one. So if I have let's say 6, so 6 can also be written as 2 multiplies 3 plus 0. So if I have 6, then I multiply this 6 is equal to 2 multiplies 3 plus 0. So we have b to be a divisor, because 2 can divide 6. And you have a quotient of 3 if you multiply against 6 plus r. So this r represents the remainder. So this is this equation that we are going to extract here. In the domain where 0 is less than or equal to r, or is less than the absolute of b, so we are not going to tackle negative numbers. That's why we introduce the absolute. So we will eliminate all negative values. So 6 is equal to 2 multiplies 3 plus 0, where the a is the 6, then b 2, then the quotient q plus a remainder. That's the remainder 0. So if you are multiplying 2 by 3, it gives us a straight 6 without no remainder. There are some others that you are going to get a remainder of 1, 2, 3, or 4, or whatever. So whatever remainder you get, then you add it. So this equation stands still. Okay, now please just subscribe to my channel. In the next video, we are going to talk about the using the Euclidean algorithm to find the GCD. If you are able to find the GCD, the GCD sometimes you are getting large values where you can't list all of them. So we use the Euclidean algorithm to find it. Thank you.